So in addition to the main resources for the textbooks, so we have the site which is up now. So these are the 3 main textbooks that we're going to use. Kind of having some trouble integrating everything into a single concept. So this one is good textbook, but somehow limited. This one is more advanced, and this one, which is actually I think is better suited for teaching, is good because it starts with digital design until the actual implementation of the processor. So somehow this textbook integrates ComSci 130, ComSci 131, and ComSci 132. But it's somehow outdated, but we're still going to use this as a reference. Okay? So please take note of these references. Again, I hope you know now how to find these great resources. So for today, we start with this one, chapter 1 of the Computer Organization and Architecture book, the Hardware and Software Interface. Okay. So basically, this is just an overview of some of the concepts, actually somehow review of 131 and some general ideas about computer systems. So let's start with computer abstractions and technology. So I don't know what computer hardware did you use? Ano yung una yung pinakauna yung nagamit na computer? i3 ba? Pentium ba? Pentium 4 siguro. Hindi niya nailagay yung Pentium 3 something. Wala na. So ako ang pinakauna nagamit ay 286 yata yun, IBM PS2 na parang laptop way back. Okay. So there is a continuing progress when it comes to the technology, especially the hardware. And as you can see, the progression as well. Yung time namin during project presentations, when I was an undergrad, I have no computer. I have to go to the com shop, install doon ng compiler or sa diskette, and then we run our programs. Then during project presentations, we have to bring our CPUs sa teacher namin, tapos doon i-check yung project namin sa CPU namin. Kasi hassle pa i-install doon sa computer ng teacher namin yung project namin. But now, okay, so somehow kahit mag-aaral kayo, nag-review kayo, nasa cellphone na yung slides or yung material. So this basically changes the way technology is used. And of course, applications also improve. Right? So with the improvement in the hardware and let's say other aspects of the technology, yung mga applications na ginagamit niya also improve. So autonomous cars, so basically Tesla. Okay? So how is that done? Okay? So cell phones, yung Human Genome Project, which was used to sequence the human DNA. It involved a lot of computers to process the data, and with that, the processing speed or the performance also of computer systems improved. Okay? The World Wide Web, which is, I think, is a very the highly utilized service running on top of the internet, and of course, search engine. So nowadays, the popularity I think is autonomous vehicles, Internet of Things. And somehow they term it as fog computing. Have you heard of fog computing? Okay, so kasi ngayon, yung cloud computing, the idea is yung data nyo, yung computation ay niraran sa remote servers, right? So controlled by Amazon, by Google, or Microsoft, those cloud platforms. Fog computing would mean yung processing will be done on your edge, or fog computer, edge computing will be done on your device. So halimbawa ngayon, meron kayong machine learning application. Hindi yun kaya ng cellphone nyo, yung computations doon, di ba? So usually, i-offload yung computation nun, yung training nun, doon sa cloud service via an API. Di ba? So the problem with that is, they say, is yung central point, single point of failure doon sa provider. Now, ang goal ngayon sa research is yung cellphone nyo dapat kaya na sila mag-perform ng machine learning or AI algorithms. So yun yung trend. So you will notice na medyo laging continuous yung improvement when it comes to these technologies. Right? So of course, we are all familiar with personal computers, and some of you might be familiar with server computers. So this itong server computers na to. This background image here, okay? So this one here is a sample of a server computer that is located in the data center of ICS. So one of our alumnus donated a few servers. Okay? So this is a 2U rack server, okay? Huawei. Okay. And then what we did is to Sir Clinton is interested in GPU processing, so we had some NVIDIA GPU. Okay. So we bought a riser card to be able to mount it on the server para magamit niya for let's say GPU programming or CUDA programming. Okay. So yeah, that's the idea. This is an example of a server computer. So there are differences in the performance, right? But basically server computers are network based. So halimbawa apat yung gigabit Ethernet ports niya, okay? High capacity, mataas yung memory niya, okay? And meron siyang RAID for storage, okay? Reliability storage, and basically it's a high performance machine compared to an ordinary desktop. Okay? Supercomputers, we don't have that here. In US, there are national laboratories wherein they have this specific design for scientific and engineering calculations like let's say climate modeling or weather prediction. Right? So sa US, China, they build supercomputers with specific architecture for very high performance applications. But sometimes these high performance or these supercomputers can be simulated using distributed processing, like let's say parallel processing, like using middleware like MPI, message passing interface. So there is no specific architecture. You just connect ordinary server computers to achieve the performance of a specific supercomputer with a specific architecture. Right? And nowadays, you have the embedded computer. So, embedded computers is not actually new, right? So, but nowadays it has better adoption. Why? Because of Android, right? So, the Android operating system has become so, let's say, pervasive that you can use it to run in devices or hardware with limited memory, limited processor. Example, nasira yung TV ko sa bahay. So I am thinking of buying a new TV. Right? So of course, the first thing that will come to mind is I want an Android TV. Kasi pag automatic na yon, okay, just plug into the network and then I have an Android. So it's actually the TV has a specific, let's say, has a processor that is able to run Android and the applications or part of the Android ecosystem. Right? So, of course, the main limitation of embedded computers is that the limited capacity in terms of memory and processing power. Right? So, this is a graph of the post-PC era. So during our time, parang ako, dahil matagal na ako sa computing, nakikita ko yung progression, lalo na sa academe. Yun na, una desktop yung dala-dala namin. Sunod, yung mga estudyante ko, laptop na pag nagpe-present. Iba, tablet. Kasi ngayon, wala na. URL na lang ang binibigay ngayon yung pag nagpe-present ng project. URL na lang. Hindi mo na kailangan. And then the GitHub repo. So, it's partially cloud computing. Okay? So, you see here the progression. Okay, so the tablet has become popular. Pero ngayon, sino sa inyo meron tablet ngayon na ginagamit? Wala na, no? So yung mga luma yung tablet, nakastack na yon somewhere, di ba? Or ano nang ginagawa? Natambak lang. So pwede nyo kalimutin yun, buksan pag-arala ano yung ginagawa nun. But it's basically, cellphone na ngayon ang pinaka-pervasive. Okay? And some predictions would somehow say na next time daw I think it's augmented reality or AR or something. So like, so I don't know how will that be accomplished. But this one shows the progression. And I think there was a news that this last year medyo madaming purchases ng desktop. Kasi parang dati nagda-die down na yung nagda-die down na yung pag-purchase ng desktop eh. So last year daw parang dumami yung pag-purchases ng desktop. Sabi ko baka sa mga gamers yun. So dumami yung mga gamers, so they need to purchase high-end desktop. So basically that's the idea. So the post-PC era would include mobile devices, so cloud computing. Okay, so there are a lot of concepts about cloud computing, but basically ino-offload mo lang yung you're just offloading the processing to somebody na more capable of managing your resources. Okay? So you have warehouse scale computers, software as a service. During our time, yung word processor namin hindi graphical. Yung WordStar ang tawag sa word processor namin. Text-based lang 'yon. 80 by 25 yung screen namin. Okay? And then dumating yung Windows, so merong GUI, may Microsoft Word. So sa desktop pa rin yan. Pero nowadays, yung word processing mo is done, let's say, using Google Sheets or Google Docs, which is actually part of cloud computing. Okay? So, ito yung sinasabi ko kanina, the portion of the portion sa cloud computing, the portion of the software run on a personal mobile device and a portion are in the cloud via API call. So, if you're familiar with web programming or mobile programming, most of the applications that you use usually meron siyang instance dun sa phone and then may API endpoints lang siya na kinocall para i-execute yung mga operations na gusto niya. So, it's a way of a remote procedure call. Okay? Specify the parameters, the cloud service or the API endpoint computes, the API computes and then returns the result, renders that. That's the common pattern nowadays, right? And you have Amazon and Google. So, some of the stuff that you will learn here were already discussed in your other subjects. For example, how programs are translated into the machine language. This was discussed in ComSci 131. And how the hardware executes them. Not that yet, but we're going to look at later when we talk about the processor. The hardware-software interface, program performance. So, how do you measure program performance? Right? There are many variables, there are many metrics, we're going to talk about that later. And then, how do hardware designers improve performance? So, in computer science, there's always this notion that if you want to improve the performance, you modify the algorithm, right? So, let's say if you have a problem of sorting n integers, and to improve the performance of sorting these n integers, you think of an algorithm that will allow you to sort that, let's say in O of n instead of O of n squared. Okay? So that's the idea sa computer science. But at the hardware level, it's also there are other metrics in addition to that. Okay? Now the connection is sa algorithm side, parang ang idea doon is it doesn't matter kung ano yung hardware. Kumbaga hardware agnostic yung algorithm. Ibig kahit anong sa cellphone mo nagra-run yung algorithm mo, sa desktop computer mo nagra-run yung algorithm mo, sa server computer mo nagra-run yung algorithm mo, parang merong certain guarantee na O of n talaga yung sorting algorithm mo. Pero yung specific time measure nun, kaya nga asymptotic yan, di ba? So, yung actual measurement will be done, of course, in the hardware. Right? So, sabihin natin na sa server computer mo niran yung algorithm na yon, siyempre, mas mabilis talaga yan. Pero yung parang asymptotic niya is O of n pa rin. Okay, you get the relationship between that. Right? And parallel processing. Okay? So, parallel processing came about because parang sinasabi ng parallel processing is two heads are better than one. Right? So if you have a hardware that computes sequentially, why not add additional and then introduce parallelism? But as I mentioned in CMSC 125, there might be issues when you access shared variables or shared data. Right? So there are many factors that affect performance. So sa CMSC 132, we are concerned with understanding how the machine works, and of course, our goal in mind is to improve performance. So as I mentioned, algorithm, that's one way to look at how to improve the performance, right? Programming language, compiler, and architecture. Okay, so during the translation process, let's say you have an algorithm to sort n numbers in linear time. You have to code that into a programming language, right? And the programming language, if it is a compiled programming language, you have to use a compiler, right? Now, the compiler will do its task of converting the high-level programming language into assembly language or machine language, right? The way the compiler does that automatic translation will also affect the performance of the program or the system. So, for example, in CMSC 131, we have what you call the jump tables, right, in implementing case statements. Right? So traditionally, when you have to implement, the compiler will use jump tables to implement, let's say, switch statements. Right? So instead of using if, conc, jump is something, it can use jump tables, which is actually faster compared to using the condition and test operations of the instructions in the x86. Right? So that will determine the number of machine instructions executed per operation. For example, going back to the case of sorting n numbers. Okay? So you write a C program, right? And that C program, you compile that in an x86 machine. So let's say you use GCC, so it will generate x86 assembly code. So meron yung mga assembly instructions na ma-generate. Now, if you have the same C code and then you compile that to a Raspberry Pi, which is an ARM processor, it will generate a different set of instructions, but it will still perform the same operation of sorting the n numbers. However, there will be some performance differences between running your sorting algorithm in an x86 and running it on an ARM processor, because of the differences in the machine instructions and of course basically the architecture, right? Also memory, right? So processor and memory. So these two are almost related. So I said ARM or x86 and the memory subsystem, right? So the memory we'll discuss later follows a hierarchy, right? So we have, let's say, registers, we have caches, main memory, and secondary storage. Now, the idea of how you might think that memory does not affect, the memory hierarchy does not affect the performance of programs or computer systems. That's wrong, because in the concept of locality, have you heard of, sa mga nag-131, of course you learn about locality. Right? So we have program locality, data locality, code locality. Right? So with that concept, the memory subsystem is actually also very important in the performance of computer systems. Let's say if you have a one level cache only, then that might be a limiting factor. So most processors, for example, have multiple levels of caches. Right? So if you have multiple levels of caches for instruction and data cache, then the performance can actually be faster, because caches has faster memory, is a faster memory compared to the typical DRAM or main memory. Right? I/O subsystem. Right? So the I/O subsystem also affects the performance of programs or computer systems, because again, at the lowest level of the memory hierarchy, the disk, for example, right, is the slowest. Right? So if you can improve the secondary storage or I/O, then you can improve the overall performance of the program. So remember, when you run a program in a computer system, it has to be loaded from the disk first. Let's say if you're using an HDD, so iikot-ikot pa yan, and then hahanapin, magsisik pa yan, and then mag-move pa yung disk drive head, which actually takes time. But if you say use SSD, okay, it will be faster. So most people, most hardware nowadays, laptops for example, use SSD because it has faster boot times. If you've heard about that, okay? Faster boot times and basically overall better performance in the system. Okay? So these are, according to our textbook, these are the 8 great ideas in computer architecture. Okay, so ilan yung 1, 2, 3, 4, 5, 6, 7, 8. So most of the things related to computer architecture revolves around this stuff. Okay, so yung Moore's law. Okay, so the idea of Moore's law is that nagdo-double yung density ng processors or ng chips. Okay? Abstraction, the use of abstraction. So the idea of abstraction, at the lowest level you have bits and bytes, then you create logic gates, and then you create circuits, ICs, okay? And then you create the processor. Okay? So that's one idea. So it always revolves around the improvement usually informs about abstraction. Actually, in computer science, abstraction is very important because parang a common person would not be, when you tell them computers understand only ones and zeros, right? The machine. But how can they do that? How can a programmer write a program to the computer that only understands ones and zeros, right? That's because of abstraction, right? The next one is make the common case fast, okay? So you start with the basic and then improve on that. Basically, ganun yung progression. Okay. Next is you can improve performance by parallelism. Okay? So we have the power wall, right? Kung saan hindi ka na pwedeng mag-pack pa ng multiple i-improve pa yung processing speed dahil sa limitation ng power wall. So instead you add multiple cores, right? So that's parallelism. Performance by pipelining, okay? So pipelining, this is part of parang instruction level parallelism. You have the fetch, decode, execute cycle. Okay? Pwede kang magkaroon ng interleaving of the fetch, decode, execute cycle. Kasi ang nagpa-power sa sa computer is merong clock, di ba? Sa 130 merong clock. Okay? So habang may pini-perform na operation, pwede mo nang i-fetch yung next instruction, di ba? So that's called pipelining. Okay? So you can do that. The next is prediction. Okay? If you can predict the next instruction to be executed or the next branch that will be chosen, then that's one. That's prediction. Okay? It's important also. And hierarchy of memory. So I mentioned a while ago, most programs based on empirical evidence follows locality. Okay? So meaning, yung mga programs na nag-execute, usually they are close to each other. The data being accessed are usually close to each other. So if you can place them in a faster memory like a cache, then no additional delays will be obtained by going through the main memory or to the secondary storage. So that's the memory hierarchy, with the registers being the fastest, closer to the CPU. Okay? And dependability. Okay? So computer system should be reliable. Imagine an airplane, okay, without considering reliability. So I think have you heard of that news about a Boeing plane? Okay? Na kung saan yung kanyang MCAS system ay nag-fail. Okay? So Without dependability, okay, then that will be a problem. Okay? And usually, dependability is achieved via redundancy. In the case of disk, or let's say we have RAID, for example. Imagine nyo, di ba you are all cloud users, right? And imagine nyo, kailan kayo naka-experience na nawalan kayo ng data? Have you experienced losing data in a cloud service? You did not experience something like that. Pero pag ikaw ang nagmamanage ng sarili mong data, you might have some corrupted files, right? So, the way that the cloud providers do that is via redundancy. Okay? So, your data is not just located in a single disk. Actually, it's striped across different data centers, across different regions. Okay, so that whenever one node fails, you can still retrieve your data. Okay? So those are some of these ideas are very important in computer architecture. Okay? So parang, okay, meron tayong kailangang bagong gawin. Okay? So how do we do that? Okay? So ngayon, nung visiting researcher ako sa KAIST, ang pinag-aaralan nila doon ay NVM, okay? Non-volatile memory or something for the disk. Okay, so parang instead of using a disk, or actually better than SSD, NVM yung ginagamit. NVMe, something like that. So, okay. Below your program. So what does this mean below your program? Ito, alam nyo na to. Basically, kung nag-131 na kayo, should know this already. Application software, Hello World. Think of Hello World, it's a written in high-level language, or Microsoft Word written in C++. Okay, so these are application software. And the next layer, so imagine ito ay parang Earth. You have the core here is hardware, okay, some layer mantle or crust or something. So the application of the crust. Actually, meron pa dyan yung user, okay, outermost. Then you have system software. System software will include compiler and operating system. So in the lab, usually 125, you have system services. So that's part of the operating system. Okay. So handling input-output. Okay. So 131, you can run a program without doing input-output. You can just examine the memory area using a debugger, or you can examine the contents of the registers using a debugger without printing on something on the screen. Okay? Managing memory and storage. So actually ito yung mga topics sa 125. Okay? So essentially 132 and 125 are closely related. Okay? Kasi we manage resources, and it's the top task of the system software or the operating system. Okay? So you have I/O controllers for USB and other devices. So this one here is an example. So basically a review. If you've taken 131, the output here will be x86 assembly code. So remember that different processors have different instruction set architectures. So x86, iba yung syntax ng kanyang assembly language. Raspberry Pi and even yung cellphone nyo, usually ARM processor yon. They have a different syntax also. So for example, this is the C code in SWAP. Okay? If you use GCC in this computer, which is x86, iba yung ma-generate niyang code. Iba yung instruction set niya. But this one is using ARM v8, so ito yung kanyang instruction set. Okay? So, siyempre, sa yung Linux or yung GCC, meron siyang support. Sino merong Raspberry Pi sa inyo? Wala? So, may Raspberry Pi kayo, okay naman na investment yun. You can do a lot of stuff with Raspberry Pi. So, you get experience to learn about ARM architecture. Pwede mo siyang install ng Linux using Raspbian. Okay? And then, you can install compiler GCC and then examine this one for study. Right? And then eventually the assembler, NASAM or GAS, will generate the binary code which represents the opcode, the instruction that will be executed by the computer. Okay? So ito na yung ones and zeros na sinasabi. The computer only understands ones and zeros. That's why. Okay? You can understand this, so you abstract this one. Too difficult, this one. More difficult, Python. So if you find C programming difficult, you can use Python. And there is a compiler toolchain that converts Python code to C code. If you don't want to use a runtime, right, for the Python runtime to interpret the Python code. Okay? So the components of a computer, siyempre pang grade 1 lang to. Okay. So you have, let's look at this one. Okay. Inside the computer, you have the input, the output, the memory, and then ito yung actually yung titingnan natin in detail, no? Yung processor. The processor has two main parts. You have the control unit and the data path unit. Okay. So remember na yung interface ng computer to the outside world is via the input and the output. And the input and the output usually they're connected to a bus. Okay? And then all the data usually should be placed in the main memory, to the main memory. Okay? So always remember that yung mga program na galing sa disk, kailangan pa rin dalhin sa memory yan para execute ng computer. And so we have the input devices, the storage devices, and of course, yung modern system, parang yung network. Okay? So merong network adapter yan for communicating with other people. So nowadays, parang ang boring na meron kang cellphone tapos hindi connected sa internet. Tama ba? Parang useless ang cellphone ko pag walang internet. Right? So it's very important also na we understand na itong network na to is basically just an input-output mechanism via PCI bus or PCIe bus that allows you to connect to the internet using some protocols which we'll discuss in 137. Okay? So, an example of an input-output will be the touch screen. Most tablets usually are using ARM processors. I'm using this for just reading ebooks, right? Not for browsing or something. Yung PDF din na-download ko dito para magbasa lang ng ebook. So, this one is an example, is a touch screen sa post-PC device. So, kailan ba ako nakakita? I think yung Apple products yata nakita ko nito na una. Kasi wala pa namang ganyan. Yung mga laptop before, hindi na touchscreen yung yung display. So, nagulat ako, galing yaman mo. Yun yung comment namin na. Kasi meron. Then, yung lumabas yung Android, yun, nagdatingan na yung mga ibang devices with touch. So, this is another mechanism. So, instead of using keyboard, you just use this particular input device and then, you got this working. And this is an example of the display, no? Inabot niyo pa ba yung mga monitor na parang TV, yung likod na makapal yung likod? Okay, so it's called a CRT, okay? Cathode ray tube, okay? So yun yung mga una naming monitor dito sa lab ng ComSci. So, but the idea is, if you have an LCD like this one, LCD screen, so nag-165 ba kayo? Hindi. So, so, usually you have to study this technology, or 161, right? So, 161 would include the concept of frame buffer. Before yung frame buffer is actually a memory area, right? Or let's say an array. You place the data that you want to place on the screen on the frame buffer, basically part of the display driver. So, if you are using NVIDIA, meron siyang device driver that connects to the memory, right? And then, and usually, kung raster yan, you have the coordinates in the screen. Let's say 0, 0, and then width, height dito. Then you draw it on the screen. You have the output. Okay, so sa computer graphics, isa yan sa mga pinag-aaralan. Actually, when alam ba yan? Nung estudyante din ako, mahilig din ako sa computer graphics. Okay? So during the early days, pag gagawa kami ng game, usually VGA yung game, VGA based. So we have to use have you played yung Doom na original? Parang gano'n. As yung Quake na So gano'n, yung idea ng frame buffer, mode 13H yun ng VGA. So yung graphics card noon hindi pa gano'n ka high end. So yung VGA meron siyang iba't ibang modes. Okay? So, the most optimal mode is yung mode 13H kasi meron siyang 256 colors. Okay? Pwede mong pagpilian and then you played, most games were implemented using that, mode of the VGA. Then, here comes SVGA. So, SVGA, medyo high-end nun, malaki na, yung mode 13H, limited lang yung dimension ng screen. 320 by 240 yata yun eh. And then, dumating yung SVGA, pwede ng 640 by 480. Tapos, 256 colors. So, medyo maganda-ganda na yung, yung display ng mga games nun. Okay? So, it's exciting time. Pero ngayon, pag gagawa kayo ng game, Unity. Okay? Unity 3D. So, you don't even understand how the underlying technology works. Gagawa ng game, kapag drawing ka ng sprite sa screen, click something to move it from one point to another, then that's it. So, during our time, ang hirap nun. Pixel by pixel yung gagawin namin. Right? So, this one is actually an illustration of the tablet. Right? So, so meron ditong, iPad 2 yata to eh. I think this is an iPad 2. Okay? So, yan, kung may mga luma kayong tablet, pwede yun ang paglaruan yun. Tingnan niyo yung mga parts. Okay? So, these are the parts of the iPad 2. So, this will be the LCD. Siyempre, kailangan may battery pack yan. Okay? And then, you have the board itself here. Okay? Then, some casing. And, you see the board here. Okay? So, A5 yung kanyang, yung processor. Okay? For this iPad 2. Okay? So, inside the processor, so if you have inside this processor, ano yung ginagawa niya? So, ito na yung basically parang culmination ng 132. Okay? Dito ini-integrate ngayon yung yung 130 concept. So, dito pa. So, performs operations on data. For example, di ba may add instruction tayo sa x86? At the circuit level, how do you implement that add instruction? How about the move instruction? How about the sub instruction? Mul instruction? And other things. So that's part of the data path, yung instruction. So basically part of ALU. Then yung control naman, it sequences the data path. Okay? So, syempre, may fetch, decode, execute cycle tayo. That's the von Neumann architecture. Paano yun ginagawa? Paano yun ini-implement? So, yung pipelining, dito rin papasok in the form of control. So, habang may ina-execute ka na instruction, at this particular clock tick, pwedeng i-fetch mo na yung next instruction. Okay, so that's the idea. And then, cache memory. Okay? So, traditionally, you see here that the memory is a separate entity from the processor. Okay? But the processor nowadays, instead of just directly going to the memory, meron siyang nilalagay dito na maliliit na high-speed memory called caches. Okay? So the technology for that is called SRAM, static RAM, compared to the main memory which is DRAM, which is dynamic RAM. Okay? So, however, the limitation of caches or SRAM is that high speed nga siya, kaso mahal siyang i-manufacture, kaya usually small sizes lang siya. Okay? So, if you don't know, for example, if you want to know that the caches in your machine, okay? So, you have this, meron ba ditong cache level? Ito. So, you have here cache size. Okay? So, ito yung kayang, kumbaga, temporary fast storage for the data na pwede nyo ilagay dyan. Okay? So, 6, MB? Okay? 6 MB. Okay? So, imagine niyo move instruction nakalagay doon, etc. So, it's high speed, but it's not high capacity. Okay? So if you zoom into the processor, so this is the processor A5 here. If you zoom into that, this will be the layout of the chip. Okay, so of the circuit. So it's a two processor machine. Okay. So GPIO, general program input-output for interfacing, for connecting to outside devices. Okay? Yung Raspberry Pi, meron din siyang ganyan. Okay? If you look at the SP of Mamiya, which actually sensing water quality attributes, okay? So Raspberry Pi yung ginamit niya doon. Merong GPIO na kung saan mo kinoconnect, several pins yan na kung saan doon mo kinoconnect para pag yung mga sensors. Okay? And then you have other devices here, and you have here the actual core, 2-core. Okay? And you have the data paths here and other components. You have here the RAM. Okay? So you have video, audio, Wi-Fi in one word. Imagine, usually ginagawa ito ng mga EE, okay? Mga EE people, okay? Para pag-manufacture naman ito. So, the big picture, okay? So, you know this already. So, we generally have a term called instruction set architecture, or ISA, right? Which provides an abstraction that allows via assembly language actually to use the hardware. Okay? And in addition to the ISA, meron din tinatawag na ABI. So you will normally hear these terms when in systems programming, ABI and instruction set architecture. Okay? So ABI is, pag sinabing interface, parang specifications lang siya. Okay? Tapos kung gagawa ka ng processor, magko-comply ka dun sa sa ABI na yon. So for example, yung x86 Linux, ano ba tayo? ABI. So for example, yung x86-64, okay? Ano yung purpose ng application binary interface? Yung pag-define ng calling convention, right? So if you take an assembly language, pag magpapass ka ng function, ng parameter sa function, merong certain convention yon, di ba? So traditionally, kung 32-bit yan, you use the stack to pass the parameters to a function. But if you're using 64-bit, right, you use the registers muna. Pag lampas na sa 6 parameters, saka ka nagagamit ng stack. Okay? So that is specified in the, I think it's in the AMD. Kasi yung nauna magbigay ng ng specification for x86-64 is AMD. And then, syempre, halimbawa, yung Linux, ang sinusunod niya yung sa System 5, for example, or sa Linux, yung Microsoft, meron din siyang ibang specification ng application binary input. So, hindi magra-run yung executable mo sa Linux sa Windows kasi magkaiba sila ng ABI. You get the idea? Pero pag halimbawa, yung Ubuntu mo, tapos Red Hat, okay? May possibility sila na mag-run pag nilipat mo as long as they follow the same application binary interface. So that's the idea. So some people still believe, usually still ask the question, sir, bakit may executable, diba parang, na-encounter nyo na ba yun? Yung parang may mga user na yung Windows program nila, gusto nilang i-run sa Linux, tapos parang pag dino-double click na lang, hindi gumagana, sir. Have you experienced those kinds of friends or family members na gano'n yung nangyayari? That will simply happen because of the differences in the application binary interface. Okay? Get the idea? So that's what I mean by that. So the next one is storage. Okay? So I think storage is very important. Okay? Everything should be in the main memory. However, when you power down the computer, everything in the main memory is gone because of volatility. Okay? So we have other types of secondary memory. Floppy disk. Nakagamit na kayo ng floppy disk? Anong klase? Yung malaki na black o yung maliit na yung maliit na iba-ibang color? Okay? So inabot ko pa, pagpasok ko dito, 1996. Okay, so black yung black yung disk namin. Maraming properties yun, may single-sided, double-sided, 3M yata yung brand nun eh. And then, meron pang dumating naman yung maliliit na lang. Okay? So, yun, inabutin namin yun. And kung mag-i-install kayo ng OS nun, Windows 3.1 halimbawa, kailangan mo ng 2 box ng floppy disk para ma-install mo yung Windows 3.1 during those days. So, that's a secondary source. Tapos, na-release ngayon yung CD-ROM. Okay? So, tuwa kami. So, isang disk, madami ka nang pwedeng ilagay. Nauso na ba yung torrent nun? Nauso na. Naruto yung download namin nun eh. Binaburn namin sa CD. Okay, and then distribute, share. Installer, ang dami kong nakuhang mga e-books nun. Dahil sa yung mga tiyangge-tiyangge, may mga may mga binibenta sila na collection ng mga software na pirated and then compilers, etc. So marami kang makukuha doon. Kasi during those time, yung internet hindi accessible for everyone eh. So pag mag-download ka ng installer, takes a lot of time. So kaya tatsaga ka dun sa mga gilid-gilid na nagbebenta ng mga installer. Na-try nyo ba yun? Nakabili kayo ng gano'n? Hindi. Download na talaga. So yan, yung mga C compiler, Visual Studio halimbawa, wala kaming gano'n. So I have to go to the illegal vendors of installers. Okay? But that's the storage. And then ang nangyari nun, so yung mga SP hanggang ngayon yata, di ba? Yung SP, CD-ROM pa rin. Ewan ko, kung meron pa kayong way para makapag-burn ng gano'n na Pero para makapag-clear kayo, kailangan ilagay nyo sa CD-ROM yung SP nyo, di ba? So, and then, syempre, dumating yung flash drive. So, tuwan-tuwa kami nun. Flash drive. So, ang dali. Parang very portable, high capacity. So, that's also an improvement in the computer system. And, ang problem naman namin sa flash drive, virus. Okay? So, pag saksak mo dito, paglabas mo, may ibang program na nando, pag sa ibang computer, may infect na naman yung kabilang computer. So, that was the problem before. So, ngayon, flash disk, okay pa din naman, and nag-i-increase yung capacity. Diba? Network. So, as I said, network's very important. Your cell phone is almost useless if you go to the province, and then you have your cell phone, and you will feel something is wrong. Okay? You will feel something is wrong if you're not connected to the internet. And we have different technologies for that. The purpose, of course, is communication, resource sharing, and non-local access. Okay? Spotify, for example. So, you listen to Spotify. So, kung wala kang premium subscription, you will not be able to download files. And then, sorry na lang, FM ka. So, ako ginagawa ko sa probinsya, FM. Okay? So, yeah. So, we stop here. Okay? So, then we'll move on later to technology trends. As a hint, I'd like you to review ComSci 130. Kasi yung mga concepts doon sa 130, like gates, sum of products of sum, min-term, max term, they are essential as building blocks in the study of, in building the data path and the control unit. Okay, so for the attendance, ano bang magandang quiz dito? Kasi wala na lang quiz, para hindi na kayo mag-iisip. Next meeting na lang. So, ganyan yung pangalan nyo sa kayo, yung day-to-day. Student number, name, student number, day-to-day. So, yung mga yung mga luma yung tablet, bili lang kayo ng precision tools, buksan nyo, galaw-galawin nyo. Gawin yung gamitin, reuse nyo yung display. Marami naman sa YouTube na tutorial kung paano i-reuse yung mga ganung stuff. Kung ayaw nyo, donate nyo sa akin. Huwag nyo lang isasama yung SD card ng may mga laman na kung anong. Okay, kung wala na kayo ito, you can pass your paper and then you can